Welcome back everyone. Like I said in the previous video on separable variable differential equations, I'm going to solve this problem. This is an initial value problem. That's IVP for short, because it has initial conditions y of 0 equal to 3. This 0 here is for the independent variable and this 3 is for y. This is what I'm saying. T is equal to 0 and y is equal to 3. That is what it means. So when we solve this differential equation, we will obtain the general solution and then we will apply these initial conditions to obtain a particular solution. That is the point. So first of all, let us obtain the general solution of this differential equation. If I look very well, this is a variable separable differential equation. That is, we can obtain the general solution by separating the variables. Let us cross multiply and see. By cross multiplying, we have this t squared plus 7t plus 3 times what? dy is equal to the t times everything here. That's y plus 5, 2t plus 7 dt. This is not what we want. We need the equation to look like this. All the terms involving y and dy on one side, and the terms involving t and dt on the other side. So I can take away this function of t to this side by dividing both sides by t squared plus 7t plus 3. And at the same time, I will take away this function of y plus 5, away from this right hand side to this left hand side by dividing both sides by what? Y plus 5. So if we do that, we are going to obtain 1 over y plus 5 dy equal to 2t plus 7 dt upon t squared plus 7t plus 3. Yes, this is it. So the variables have been separated purely. So what we have to do now is to integrate both sides. Okay, so let's take the integral of both sides. The integral of 1 over y plus 5 dy is actually the natural logarithm of y plus 5. Yes, because the derivative of y plus 5 with respect to y is 1. In the previous video, I established this fact. If you have a function such that the derivative of the bottom is the numerator or the top, the integral of that function with respect to the variable is the natural logarithm of the bottom. So what would this be? It's equal to, we're also going to make use of natural logarithm here. T squared plus 7t plus 3. Differentiate it with respect to t. You will obtain 2t plus 7. That's it. Differentiate t squared with respect to t, you have 2t. Differentiate 7t with respect to t, we have 7. Differentiate 3 with respect to t, we are going to obtain 0. So this is the derivative of the denominator. And that's exactly what we have here. So the integral of this function is the natural logarithm of t squared plus 7t plus 3. Then I add the arbitrary constant c. I want to apply the initial conditions when t equal to 0 and y equal to 3. So t equal to 0 and y equal to 3, or y equal to 3 when t is equal to 0. So in place of y, I'll write 3. In place of t, I'll write 0. So this is ln 8. 3 plus 5 is 8, equal to ln 0 squared is 0. 7 times 0 is 0. We have just 3 left. That's ln 3 plus c. So ln 8 minus ln 3 is equal to c. This logarithm here is natural logarithm. That's log to base e. Okay, they have the same base. So by logarithm, we can say c is equal to ln 8 upon 3. That's what logarithm says. For logarithm that have the same base, if you are performing subtraction, you divide the first number by the second one. All right. So this is the arbitrary constant C. So to obtain the particular solution now, we are going to replace this C with ln 8 over 3. So ln y plus 5, are coming from here now, is equal to ln t squared plus 7t plus 3 plus what? Ln 8 over 3 in 8 upon 3. Alright, let's simplify that right hand side. This is ln y plus 5 equal to, by the law of logarithm now for addition, they have the same base, log to base e, log to base e. I'll multiply these two. Multiply t squared plus 7t plus 3 by 8 over 3. And that will be what? Ln. Okay, this is 8 all over 3 into t squared plus 7t plus 3. Alright. Let me just take away that one at the top. Let me take this away. So we have this now. Ln y plus 5 is equal to ln 1 over 3 into 8 times t squared is 8t squared. 8 times 7t, that's 56t. 8 times 3 is 24. So to take away the ln from both sides, we exponentiate both sides. Alright? E to the power of ln y plus 5 is equal to e to the power of ln 1 over 3 into 8t squared plus 56t plus 24. So e will take away the ln, e will take away the ln. By the law of logarithm, you have a to the power of log b to base a. The a here will take away the log and the base a, leaving us with the b. So that's what is happening here now. So y plus 5 is equal to 1 over 3 into, we have 8t squared plus 56t plus 24. So I can take 5 to the other side. Y is now equal to 1 over 3 into 8t squared plus 56t plus 24 minus 5. So this is the solution to that initial value problem, the particular solution, given that t equal to 0 and y equal to 3. So this is how to solve differential equations by applying the initial conditions. Thanks for watching. I hope you enjoyed the video. Keep supporting by subscribing to this channel. Like this video and share to your friends and to your classmates. I will see you in the next one.